Hi, this is Jeff from the Ozark Mountains in Missouri, USA. Well, you remember on the last video, we took a look at these two Casio VX4s that I got in a box of stuff from auctions in Japan. One of them we got working, it had an LCD problem, and the other was dead. It had some serious battery corrosion problems, and just wasn't really sure if we would be able to save that corroded out keyboard PCB or not. That was on a Saturday. I got the video done, edited, released to Patreons, and everything was good. And I thought, no, I'm not going to work on this right now. I don't even know if it's fixable. And I was happy, and I went to bed. And Sunday morning, I woke up with two revelations. One was I sent some of the Alps plotter gears to Japan, but I sent 10 gears instead of 10 sets, so I had to send off another box of gears right away. And the other was I just had to try to fix this other pocket computer. I just had this burning desire to try it to see if it was even possible, and so I set off on a mission to see if it would ever work again. And that's what this video is about. So let's jump in and see how the process went. This video is brought to you by PCB. It's easy to jump on their website and get your quick quote for your next circuit board. They also offer CNC services, 3D printing, enclosure making, everything you need for a complete product. They also do surface mount and through-hole assembly, stencils, and a range of other products and services. If you need advanced circuit boards like flex boards, microwave boards, that type of thing, they got you covered there too. Whatever your PCB or prototyping needs, PCB has you covered. I woke up this morning with an overwhelming urge to try and go ahead and fix this VX4 keyboard PCB. So the first thing I did was tin up all of these traces that had previously been corroded. And that's a good test to see if you've got them clean. If they're not clean, they won't tin up very well. So got those tinned. And you might be able to see just there, I have one repair segment in place, and I'm just using some tape to hold it down. And you can see where the ferrule comes through on the bottom, and I tested from continuity from the carbon to the trace, and that works. When I'm done with all these repair pieces, I'll put a little dot of conductive ink or conductive paint over that, and hopefully that'll do the job. I thought I would try to show you how this process works. So we need to drill out the bad ferrule, which you can not quite see right there is where it should have been, right where the drill bit's pointing. And then we have a trace repair segment right up here at the top of the frame, and there's a little bitty ferrule which come out of this box here. This is from an old Pace repair kit that I got on eBay. I mentioned in the other video that I had a safe search that I let run for a long time until I found one of these that popped up that was affordable, because if you buy these new, they're a couple $100. They're rather pricey. Okay, I'm going to be blocking most of this shot here, but I'll do as good as I can. So I'm just using a little carbide drill by hand so I can feel it. Copper and brass are really difficult to drill because they tend to grab, and it's really easy to break the drill bit. So I go in a little bit, rotate it a little bit, rotate it counterclockwise, and trying to find the correct hole in the back. It's the one by the bend right there. And I'll drill it from the back a little bit. Same type of thing, which you can't see because my big hand is in the way. But there, that we've made it all the way through. There we go. To the point we can pull the drill bit back out. Now we have a hole large enough for the ferrule in there. And I'm going to pick up this trace segment. Set him in place like this. Pick up the ferrule. Actually, I want that the other way around. These are little difficult buggers to get a hold of just right. I've got this circuit board sitting on an old scrap of t-shirt material to protect the carbon on the bottom. Try to keep it from getting scratched or dirty. There, okay, now we've got the ferrule pushed down through the board. This is a little homemade tool. This is one of the official Pace tools. This is a 1/8 inch carbide bit that was broken, and I just ground it to a point. I'll put that right on the board like that. Turn this whole mess upside down. Then I'll use the official Pace tool here to flare out the back side of that like that. And I also have a homemade version of the same tool. I'm going to use this other part of the official Pace tool incorrectly and just try to flatten that out really good on this side. Okay. Yeah, there we go. We've got a trace repair segment in there, and as I said, when I'm done, I'll put a dot of conductive ink or conductive paint on each of these on the carbon side, and hopefully that'll work. So I've got a few more of these vias to fix, and then I need to take some sections of these trace segments from these sheets and fill in the breaks that are all over the board. And then on the top side where the ferrule goes through the copper, you can just put a dab of solder there and that'll hold it perfectly. Like once I get this trace segment in, which joins to here, I'll go back and put some epoxy under here, and I'll show you that to hold the trace in place. And then when the epoxy is cured, we can top coat that to protect it. A few more hours of work to try to rescue this board, but it should be interesting to see if it actually works afterward. A bit of an update here. The 3 areas where we had problems with vias being bad have been fixed, and I've patched in all the rest of these traces here, and I've put some flags where I still have some breaks to fix. This one's kind of tricky because it goes to this printed resistor, which is about 220 ohms, so worst case I'll figure out how to bodge in a little surface mount resistor there. So this is going better than I thought, but I've spent about 2.5 hours so far on this, and when I'm done I'll have to clean it really good and make sure there's continuity everywhere there should be continuity. And oh, there's another break right there and there. So 6 more I have to do. And make sure there's no continuity where there shouldn't be. And then we can give it a try. I'll try to give you an idea of what I'm seeing through the magnifier here. This particular trace right here has a big chunk out here, but it's got a smaller chunk out there. So this has all been cleaned and tinned. And I cut a little section of trace out of this guy. I trimmed it off to the right length. This is really hard to do under the camera. Which I will set down here in place like this. Try to get it into position. And the stickiness of this paste flux actually helps here. I'm gonna get a little solder on my iron. Try to nudge that repair segment in place. I'll hold down one end and tack it. Try to get the other end in position and tack it. And these particular repair pieces I have from this Pace kit are kind of old, and they're a tin coated copper, but they're kind of oxidized, so it's taking a bit of flux and a little longer heat than normal to get them to solder. There we go. So now we've got our repair trace segment in place. I keep shaking the thing. I did this one as well. There's still one here where this resistor went. And oh yeah, this stuff right here, which is a little more difficult repair. A few more to fix, and then maybe it'll work. Well, here we go. We've got everything patched up. If you look real close from the edge, it looks rather bumpy, but it's kind of deceiving. The solder really doesn't stick up that far, but you know, it's all relative. I ohmed out all the traces. Everything seems to be going through now. I was even able to solder onto just this edge of what was left of the copper here where this printed resistor is, and that's fine. If we look at the other side, you can see where our 3 repair via ferrules come through. So I'm going to take this Casio 44, which comes in this little silver bottle. I've used this to repair a rubber keypad for a friend, and I will dab just a tiny bit on each spot just to kind of seal it and help it make a good connection over time. Just need to shake this up a little bit first. I'll let that dry, and then we'll coat this side with this overcoat pen. I was thinking about using an overcoat epoxy, and I thought, well, this stuff doesn't have the temperature rating, which I don't really need in this case, but it might remain a little more flexible, which might be good since this is a keyboard and you're going to be punching on the other side of it, so maybe this would be the stuff to use. So, okay, I've got this shaken up. I'll put just a little on this. It's like a real pointy Q-tip that comes with it. Just try to put a thin coat over it like that. It's rather messy in some areas, isn't it? But I think that'll do what we need. Should work fairly similar to what they originally did by printing the carbon over the original ferrule that was pressed through there. Okay. I'm going to take one of the second little pointy Q-tips that came with it and try to... These are great, but they're rather fuzzy. There we go. Still a little messy, but that'll do the job. So we'll give this a few hours to cure, and then we'll seal the other side of it. I've got my Circuit Works overcoat pen now, and I've mixed it up good and kind of kneaded it. It separates inside. So if you haven't used it in the last little bit, you need to spend a lot of time mixing it and then take a little alcohol and clean the tip off. But the general, and then I took my finger and kind of touched each of these joints to make sure there was no little solder stalagmites sticking up, and I trimmed a few off with the X-Acto knife. So now I'm gonna, now you can't see that with my hand in the way, but just apply this all over. Mainly worried about where I've kind of patched it here. Apply kind of an excess there to help hold those bodged in trace segments down. The other thing I got to thinking about is that there is a sticker that sits over here which will help protect this area. But the battery's set right here. And part of the case bumps up against there, so we want to make sure that it's not going to prevent the case from coming together or something like that. And I don't think so. I don't think the clearance is that tight. Got this via all the way up there. Okay, looks like we've got a good coating on everything. You can heat this up and it'll cure faster that way, but I usually just let it set about 24 hours. Let it cure nice and good, and then we'll try reassembling this guy and see if it actually works. Okie dokie. I've got it all back together. I cleaned up the sticker that goes on here, but I haven't stuck that down yet. These screws that were a little rusty here, I soaked in some citric acid and then soaked all of them in WD-40. And I was able to reuse them that way. I've got my bench power supply hooked up here because we still have the rusted spring problem. And we'll go ahead and kick this guy on and see what happens. I think first we need to turn the backup battery on. Turn the power supply on. And, well, it's very disappointing. We get nothing. Okay, that slight delay brought to you by a broken wire on the black clip lead here. And I found out that these have an actual key test built into it. If we type in system asterisk and hit 2 for key test, and it'll start here, and we just press the button and it'll beep and go on to the next one. It prompts you which button to press. And then it starts in this corner. We're all good. So amazingly, all our keyboard patching there worked. Now we still do have to worry about the battery compartment though. Let's take a quick look at that. So here we're missing a spring. It rusted off, and this is just like a piece of wire that goes all the way over to here for the next positive contact. And I don't have this part exactly. I've got an old AA battery pack like this, which is close. Might be able to take this out of here and connect the two together. And I've got a bunch of these old battery packs like this, but they just have a metal plate and a spring, but the spring is a little longer than what's needed. so it maybe I can solder the spring onto this loop of wire. So the first step though will be trying to pull this out. It's kind of clipped into this part. I think if I push that down, I can pull the wire out and slip that whole loop out of there. Let's give it a shot here. Oh, about that. That wasn't so hard. You can see this side is fine. This side really had a number done to it. So I'll have to see what we can do for that. Okay, I took the display unit back out and I put some Cap-10 tape over the areas where the patching had been that's kind of under this display bracket, just as a little extra protection against abrasion. And I took some of this thin Scotch double-sided tape, I love this stuff, and I put it under this label here and stuck it back down. I figured if I ever need to pull this back up to work on those patches again, that'll be a lot simpler, and besides that, it's kind of trapped under here anyhow. As you might notice, there are some batteries in this guy. Let's take a look at the battery compartment. As you can see, we have a spring in here, but it's not exactly like the original spring. I cut it out of this battery pack, which had a wire going over to like a rivet right here. Then I bent that wire and pushed underneath this part, which was the positive contact from the original set. And it works. It's a little ugly. It's a bodge, but until I can find a piece that matches the original a little closer, that will do. Speaking of batteries, one thing I found out on this is that if this memory backup battery is dead, it is really difficult to get this thing to start up correctly. It just doesn't want to do it right all the time. And I think what this is saying over here is that when you're going to replace the memory battery, turn this guy off, replace the memory battery, put your main batteries back in, and then turn that on, and it'll start up right in that order. If you don't do it in that order, it doesn't seem to work right. I think if you just are replacing the main batteries here and the memory battery is still good, you don't have to worry about that. So what is left to do besides snap it together? Well, these little rubber feet that are supposed to be in the corners are missing, except for this one. And I found a sheet of rubber about the right thickness, I think. And I drew up the size of those, measured them, and made a drawing because, yes, I am that nerdy. And these are the little rubber pads that are actually inside this slip cover. So I noticed on the VX4 unit number 1 that those were kind of worn out and the slip cover was way too slippy. So I'm going to try to take a knife and a straight edge and cut some pieces of this rubber out and stick it down with Mr. Double-sided tape here. And I think other than polishing the LCD up on the other side of this and the slip cover up like we did with unit number 1, I think we'll have it taken care of. We'll see what it looks like when it's all done. Okay, this is actually unit number 1. I'm catching up on a few things on it. I took my little sheet of rubber to work and used kind of a bench top shear, which is sort of like a paper cutter, and cut off some strips, or this width and the width that goes on the sliding cover on the inside. And then I used this ruler thing taped to a piece of plastic to cut off some little chunks like this, which I will stick in here for these feet. I've already done these 2 feet right here. They're a little taller than this, but that's just fine. So I'm using my super duper double-sided Scotch tape here. I'll just pull off a little like that. Stick my bits of rubber down. Neatness does not count here, just get it stuck down. Okay. And then I'll cut each one of these out of here with the scissors. That way I'll wind up with some double-sided tape just on the bottom. Try not to touch the part I want to stick down. But that's easier said than done sometimes. Okay, I've got one like that. I'll just pop him into the hole like so, and then I'll do these other three and I'll show you how we do the slip cover. Okay, this is unit number one. We just put the 4 feet on. Those work really well. It doesn't slide all around now. And I've already done the rubber pieces on the inside of the slip cover, and you notice that this will slide off easy enough, but it doesn't fall off. It's kind of hard to see these guys because they're black on black, but they are these guys just right here. On unit number 2 here, this is much more loosey-goosey, and it just kind of falls off of there, which is not ideal. Very easy to slip out of your hand. So you can see the piece right here. Now this original one is kind of tapered like this, so when it's sliding it's not catching on the edge. And the ones I made are flat, so we're going to have to overcome that. The hardest part with this operation is getting the old one off of here, and I'm just taking a small screwdriver and very carefully working under the edge. These tend to be really well stuck down, I have found. Okay, it's getting there. I don't want to go too wild and let the screwdriver go flying and break something. But I think you get the idea here. We're just scraping that out of there. Okay, that one came out nice and clean. Make sure there's nothing left in the corners. Give that a wipe down with a little bit of alcohol here. I've already wiped down the new rubber pieces with alcohol. Just like that. Make sure we get all the crumbs out of there. Okay, I'll test fit this piece to make sure it fits in there. Yep, nice snug fit. As a matter of fact, I can't get it back out. Screwdriver to the rescue. Okay, got that scraped out of there, and now for the tricky bit to give us that curved front on our rubber piece. We'll pull some tape out like this. Pop that down there in the middle. I lost the scissors. Okay. And I lost the tape. This video is brought to you by gravity. Okay. Now, get rid of that piece of tape. I picked up some carpet fuzz on it. Okay. And we'll put a second layer down there. We're just making the middle thicker, which gives us our bump that we need. Again, trim that off there. Pull off a bunch. Plop him down there. And trim off the tape around it. And we just need to do like we did with the little squares, go around the edge. Trim all the excess tape off of there. That'd be better if we weren't touching the bottom of the tape a little bit, but it still works. Then we need to pop this guy into place like that. We want to make sure the corners get seated in there really good. Okay, now we have a slight bulge out in that piece of rubber. It's not very big, but it was just enough to work on the other one. Okay. So what I did on the first one is I did one at a time and then tried it. You see, now this is just doing one side on this one is adequate. It's got a good amount of friction there where this cover is not going to fall off. I can do this and I can still take it off of there easily. So just do the one side on this one. So now both units have 4 feet and a cover that won't fall off. And we've got our 3D printed expansion port cover here. Somehow I completely forgot to record anything about the expansion port cover. Unit number 1 was missing the cover, so I took the one off unit number 2 and created a 3D model and printed one out to put on unit number 1. I put this model up on Thingiverse, and the link is in the description down below. Most excellent. And they're both even reasonably shiny now. I think I did a little better job shining up unit number 1 there. What do you think? Yeah, I think this cover's not quite as shiny, but it's fine. It'll do the job. Oh yeah, you can tell the reflection here, can't you? Yeah, this one's slightly shinier. Well, what do you know about that? I was really quite surprised that we got that second unit going. It's working like a champ. It took a lot of patience and about 4 or 5 hours of time to fix all those tracks and reseal the board. The little bits of rubber for the slip covers and the feet, that wasn't that big a deal. It didn't take very long, and it just used some rubber and some tape that I had on hand. This Pace Cir-Kit repair kit was invaluable. These are great. As I mentioned, they're really expensive if you buy them new from Pace. I got a couple of these off of eBay by doing a safe search and letting it run for months and months until they popped up at an affordable price, and I grabbed them. So I'm all set now. I also have some similar repair parts from China, so maybe we'll do a video later just about using those and different methods and doing some more extreme circuit board repair. Let me know what you think about that. This has been a lot of fun, and I learned a lot. That carbon printed board, trying to repair one of those, that was a new one. Never tried that before, and I'm surprised, really surprised that it actually worked. If you have any questions or comments, well, you know, just leave them in the comments section down below. I would love to hear from you. And a special thanks to everyone who helps support the Hey Birt channel through Patreon and other means. Your support is greatly appreciated. If you would like some more information about that, well, if you look down in the description below, there's a few links there. Just click on those and you'll find out all about it. Well, until next time, bye.